Okay, welcome back. Now we come back to the example that we did the other day. Remember, we were doing a speaker that was 6 meters long. It was from -3 to 3 meters, and the total power output of the speaker was 100 watts. Let's take that speaker and now put it in the shape of a semicircle, and let's now calculate the total intensity at the center of that semicircle. Let's see what we will get. Okay, so if we take a piece of the speaker like this, which has a power dP, right? So we can use the same argument, di is equal to dP over 4 pi r squared, right? Then we integrate along all those pieces. So what does r squared represent? Well, r squared represents the distance. R is the distance from that piece to the center, right? Then we're doing r squared. Now if we integrate this, we can do the same process as before. We get the intensity is equal to, remember we did dP is equal to lambda dx over 4 pi r squared, right? So now in this case what happens, as I go from piece to piece to piece, right, as I go to this piece, the r actually is not changing. All of the pieces are uniform distance from the center. So even if the piece is here, it's still r, right? So what ends up happening is actually the 4 pi r squared comes out of the integral, and you get 1 over 4 pi r squared. Then you get lambda dx, which is basically, it's just saying like, it's basically back to the integral dP, right? Integral dP, which is equal to just the total power. So then it just becomes p over 4 pi r squared. It's going to be 100 over 4 pi. So now if the length of the semicircle is 6 meters, what is the radius? Well, we have the length of a semicircle is equal to pi times the radius, right? And remember, the circumference of a whole circle is 2 pi r, so the length of a semicircle is pi r. So this is 6 meters is pi r, therefore r is equal to 6 over pi, and then that's in meters. Then we're going to take 100 over here divided by 4 pi, and then the r squared, so it's going to be 6 over pi quantity squared. Okay, so then you're going to have here 100 over 4 pi, and then 6 squared is going to be 36 divided by pi squared, and then one of the pi's is going to cancel with one of the pi's down here, and then you can say this pi is going to go to the top, right? And then 4 is going to go into 125 times, and then we're going to have 36. That's actually going to be pretty loud. It's going to be over 120 decibels, right? So then pretty loud. So remember, this applies to not just if a speaker is in a semicircle, it could be a stage where a concert is being held, and if the total power output of that stage is 100 watts, and if you're sitting right at the center, then you will be hearing 123.4 decibels of sound intensity, right? Now, what if the density, if the sound density is non-uniform, right? Does that make any difference if the sound intensity is non-uniform? Remember, we did the intensity lambda is equal to alpha x squared. What if this portion of it, the two ends, is louder, and then the middle portion is not loud at all? Is that going to make a difference? At first, you might think, yeah, it will make a difference because this is louder and then this is not loud, so there's got to be something that it has to affect. But in reality, in this case, it will not make any difference because since intensity is a scalar, it really doesn't matter where the loud music is coming from. You are still equidistant from every point, right? So since you're equidistant, they still add up like a number, and then the total sound intensity ends up being it's the same. So in terms of the integral, you can actually see here why it doesn't matter. If the 4 pi r squared is uniform, it comes out of the integral. This is lambda dx is dP. So it really doesn't matter if the lambda is uniform or not. Lambda dx is always equal to dP, whether lambda is a uniform function or it is a non-uniform function. So since this part was non-integrable, it came out of the integral, then this became dP, and then integral dP is still p. So no matter what, it's always p. So then you just have to worry about the total power output, which is 100, and then divide it by 4 pi r squared. So the distribution of the sound intensity in this case does not affect the total intensity that a person hears here at the center, okay? The next example I'll do is I'll put the person off the center, then I'll say, does that matter now? Is that going to make any difference? Okay? Thank you very much.